Good morning or good afternoon. Hi, thank you for watching again. I am Katie Ducker. I'm the product manager of the Medis Suite MR product line at Medis. Today I will give you deeper insight in the deep learning algorithms for the long axis contours. Let's go to the program and show what has been embedded in there. There are different ways that we can create or make use of the deep learning algorithm for the long axis contour detection of the left ventricle. The first way is to create an autocue file based on the input of our long axes. We can select the 2, 3, and 4 long axis series, go to the autocue option, and select here the contours for the long axis. This way, you will see a working man here appearing up front. This means that these three series are now going through the algorithm, and based upon that, the contours will be detected. We can check the status of how far the algorithm is in the autocue status bar. Here we can see that the status is still in progress. And in the end, we can also see how far along we are. So in this case, at 81%. We can also see for which patient it has been chosen. And as you can see, we can also see when a process is finalized. You can see this is an additional tab, which we can also close. So now you can see that an additional series has appeared called the autocue QMAS LV contours for the long axis, based on the algorithm of June 2021. Now, if we open the patient, after we do the regular viewing, we can select the 3 images and go to the QMAS application. In here, based on the autocue file we have in here, it will recognize the different series and it will create the contours for the different series on both the ED and the ES phase. So it will do that also for the 2-chamber and also for the 3-chamber view. By default, it will only create the endocardial contour for the ED and the ES. This so we can easily transfer it to the strain application and get there the global longitudinal strain. So if we click here now on the strain icon, we will launch a strain application. Those contours which were created will then send towards here. We can select different series for the different in the right order for the different long axis parts. And based on that, it will now do the tracking and will give us the results in the global longitudinal strain, among others. So here you see now, based on those endocardial contours, we will get directly our global longitudinal strain. And as said, also other parameters are now available in here. So this is the first method we can do. We can also make use of the autocue file if we want to have like all contours for the whole slice, or if we only want to do it, or if you also want to have the apicardial contours. So let me go back therefore to the QMAS application. If you also want to have the apicardial contours or all contours, we can select here, for example, the AP contours. And now if we drag and drop the autocue file in, we will get for each series now also the apicardial contours embedded, still only at ED and ES time frame. If we press our Shift button and drag and drop it in, you will see that now all the contours have appeared for each of the different phases. So this way we can make use of the pre-processing autocue file and get either only the endocardial contours or also epicardial contours, or for the entire frame or only for the ED and TES. The second method is to use the contour detection method within the QMAS application itself. So let me therefore go to a different case so we can start from scratch. So let's make sure that there is no contour detection autocue available for the long axis. We can load the case as usual. We can select the different series and go to the QMAS application. Now, since there is no autocue file in here, also no contours have been detected. However, we can make use of the auto button. If we click on that, the contours will also be generated based on a deep learning algorithm. We can then select the diastolic phase. Last one. And then we can select either if you want to have the endocardial contours or both, also the epicardial contours, if you want to detect it in the entire slice or only for this image. And then press on detect contours. Based on this, it will detect the contour, and then we can select the end systolic phase. And again, click on auto. This way we will get our ejection fraction based on these contours. As said, we can also apply it to a whole slice and also for the epicardial contours. Now, if we detect the contours, we don't need to define ourselves the ED and TES phase because it will do it for all phases. And you can see here in the bottom the progress of the deep learning algorithm. And you can see now also the contours are made for the entire cycle. Thank you for watching. I hope this is helpful for you. Let us know if you have more requests for specific videos. I hope you give this a thumbs up. And please keep on liking, sharing these videos to make sure we will make some more for you. Thanks again. See you next time.